Okay, good morning. So now I'm going to start unit number 3, dimensional analysis, as well as for civil engineering student as a mechanic, as well as for the mechanical engineering also. The same topics is very important. So what is dimensional analysis? What is dimensional analysis? Yeah, listen carefully. So dimensional analysis is basically for what purpose you are going to use the dimensional analysis. Let us see, if you want to design a used equipment like a centrifugal pump, a turbine, a aeroplane or a ship, like if you want to design everything used equipment machinery, like that, in that one so many parameters will be there, so many equations will be there. Let us say let us take two equations. Suppose let us take one equation. Suppose F is equal to mMdx. Let us take one equation, and this is the equation number 1. Let us take second equation. So pressure is equal to force per. So pressure is equal to force per area. So then F by A. P is equal to F by A. And let us take another equation. So tau is equal to mu into du by dx. Okay. So this is Newton's law of viscosity, and this is the pressure equation, and this is the Newton's second law. In that equations, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the three equations, we have around 10 parameters. 10 parameters. Let us say something repeated, F is repeated, here F also repeated. Like some other equal is around 7 to 8 parameters will be there in the equation. Just simply you are going to simple force equations, you are going to find out a simple force equations. In that one we have a 3 equations. In that one we have 7 parameters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like around 7 to 10 parameters will be there. So while you are designing a centrifugal pump or reciprocating pump or a turbine or an aeroplane or a ship, in that one so many parameters will be there. Like thousands of parameters will be there. And coming to units, so how can you define the force? Newton, kg, mass, kg mass, acceleration meter per second square. And let us take here tau. So tau is equal to Newton, viscosity, kg meter per second, velocity, meter per second, distance, meter. See here, for regarding 3 equations, we have 10 parameters, and that 10 parameters we have a number of units will be there. So 3 equations, 10 parameters, so many dimensions, units will be there. So there may be a lot of confusion, lot of what do you call that, you have there is no clarity, there is full clumsy. So for that purpose, so we are going to explain about dimensional analysis. So in the dimensional analysis, we can use dimensionless numbers. Let us take RE, dV, rho by V. Reynolds number, Prandtl number, Cp mu by K. Fr, Froude number what? V by root GD. See here. So these are all called dimensionless numbers. Dimensionless numbers, nothing but in that. So just there is no units for these equations. No units. So here d is the dia, d is the velocity, rho is the density, and mu is the viscosity. If you cancel all the units from at the top and bottom, so no units for these 3 numbers. Like so many numbers will be there, like Prandtl number, Nusselt number, Grashof number, like so many numbers will be there. So these numbers we can develop by using dimensionless analysis. Are you clear? So once again repeating, while designing anything equipment, so many equations will be there, and from that equation so many parameters will be there, and from that parameters so many units will be there. So there may be there no like LHS is equal to right HS generally. LHS is equal to RHS. So that means what? The left side equations must be equal to right side equations. So while designing so many different equations or so many machinery parts, so many equipments, so there is no LHS is equal to RHS. So in that problematic area, then you can go for the dimensionless numbers. So let us see what is dimensionless analysis. It is a mathematical technique which makes use of the study of dimensions for solving engineering problems. So for the math, it is a mathematical technique. So by using the what do you call that, equations, so you can use the mathematical technique which makes the use of study of dimensions for the solving engineering problems. That is called dimensional analysis. Yeah, what is the advantages? It expresses functional relationship between the variables in the dimensionless numbers. Already told. So these are the dimensionless numbers. It expresses functional relationship between the variables. So these are all called variables in the dimensionless terms. So by using dimensionless terms, it reduces the number of variables involving physical phenomena. It reduces the number of variables because it reduces the number of variables. Yeah. So in that one, if you are directly can't put these equations, these parameters. So these are all coming from the methods of dimensionless analysis. There are two methods of dimensionless methods: Rayleigh method and Buckingham-Pi theorem. So by using these two methods, so we are going to design these all methods. Let us see. Suppose discharge. So what is dimensions? So that you have to know. Suppose a discharge Q. So Q is equal to A into V. So A is units for area, meter square, and velocity, meter per second. Okay. Now this is the equation and this is the units. So this is the units and this is the equation. So now dimensions. What is dimensions? Yeah. So meter square, you can define in the length L. So length square. And M also length L. And time T. Small t capital. So L into L square into L. L cube by T. We can write as L cube minus 1. So this is the dimensions for the dimensional analysis for the discharge. See here, discharge equation, discharge units, discharge dimensions. So you can do all the whatever the equations will be there, then you can do the dimensional analysis. Thank you.